access control list. Okay. Write down the definition for access control list. When we want to filter, when we want to filter, users information, when we want to filter users information on a router's interface, either inbound or outbound direction, is called access control list. I'll repeat once again. When we want to filter users information on a router's interface, either inbound or outbound direction, is called access control list. Am I audible to last pins, right? Okay, next point. Access control list is a set of rules. That is used to filter the network traffic. Access control list is a set of rules that is used to filter the network traffic. Okay. Next point. With the help of access control list, a traffic can be, with the help of access control list, a traffic can be either be permitted or denied. Either permitted or denied. Okay. So first one, when we want to filter network users information on a router's interface, either inbound or outbound direction, is called access control list. Okay. So access control is a set of rules that is used to filter the network traffic, and with the help of access list, either it can be permitted or denied. Okay. Now I'll explain you. Okay. So here I have R1, R2, and R3. Okay. So if I want to filter network traffic, means see, I've given the routing. Okay. Everywhere routing is there. For example, I will say this is 1.1.12.0. This is 1.1.23.0. Okay. So this will be what? 12.1, 12.2, 23.2, 23.3. Correct? This is fine. Now, I've given the routing. So will I be able to ping from R1 R3? Yes. So the communication will be there from this end to this end. Once the routing is given, once you give the ping will work. Correct? Can you block the ping? No. Once you give the routing and the interface is up, and if you give the ping command, obviously the ping will work from R1 to R3 or R3 to R1. Correct? That is your connectivity. So for example, R1 is my employee, R3 is my manager. Okay. So R1 should not ping to R3. That means the employee should not ping to manager, but the manager can ping to employee. How you are going to do it? That is your access control list. So what we are doing, we are filtering the user's information. Okay, where we are filtering, that is on the interface. Either R2 interface we are giving or this interface. So we have gig 0/0. and gig 0/1. So on the router's interface, we are going to filter the traffic. This R1 traffic will be filtered on this R2's interface. Okay, so clearly understand the definition. When we want to filter users information, that means R1 cannot ping to R3. That is filter the users information. Okay, where on this router's interface we are doing it. Okay, and there is one more thing, either inbound or outbound direction. A traffic can be permitted in two ways, permitted or blocked. First of all, only two things are possible. Either it can be permitted or it can be denied. Only two things. If I have to send this R1 to R3, I will say permit. If you have to not send this R1 to R3, I will say deny. Only two things are there. So where I will do it? On this router's interface. Correct? In the router's interface, we say inbound or outbound direction. Okay. So if I'm pinging from R1 to R3, say, how the packet flow will be? From this side to this side, correct? So it will go via R2. So this interface is called in interface, inbound direction. Okay. And this interface is called out. That means outbound direction, because it is going out and this side it is coming in. For example, this is your gig 0/0. Okay. This is my G 0/0. And this is my G 0/1. Okay. Okay. So if I'm going to filter this R1 to R3, I'll go via this direction. Correct? Go via this direction. And this will be gig 0/0 will be the inbound interface. This is very important. Whenever you're giving the command, you're going to use this in and out. So clear understanding should be there. Then only you will be able to perform the practicals. Okay. So this interface is called inbound direction. That means packet is coming into the router. So gig 0/1 will be outbound direction, because packet came inside this router and it's going out via R3. So this is called outbound direction, out interface. Okay. Okay. If the scenario is like this, from R3 I have to block to R1. Okay. So in this scenario, gig 0/1 will become inbound direction and gig 0/0 will become outbound direction. So likewise, you can differentiate. So this is how we are going to filter the traffic on the interface of the router. Okay, clear? Now I understand what is access list. So 4 access list we are going to learn. Named extended, numbered extended, named standard, numbered standard, named extended, numbered extended. 4 practicals are there. I'll show you all 4. Okay, so today we'll see all 4 practicals. How I'm going to, what is the difference between named, what is the difference between standard and extend, everything we'll see. But before that, you should understand what is access list and why it is required. Okay, so this is the use of it. You will learn a lot of access list, control list in your upcoming batches. That is your CCNP, advanced, SD-WAN, your fire, especially firewalls. You will create multiple access control list because you're going to block a traffic. Okay, so you will be learning all these things there. Okay, so after that, any doubt on this? All clear? Okay. Now I'm going to explain you.
Sir, 1 second. Hello.
Yeah.
Here R1 should send traffic to R2. R2 should not send to R1. Like that, no.
No, no. R1 should be denied to R3, I'm saying.
Hmm.
If I have to directly connect it, I'm not going to block it. I will block it in the WAN side only, not on the directly connected. Why will I block these two interfaces? In that case, I can
Uh,
simply shut
no,
down
no. Sorry. Mistakenly I told R2. I meant R1 and R3 only.
R3. Yeah, that's what I'm saying. R1 and R3,
Hmm.
you can't do it on the same router. You have to do it on the middle routers. So
Middle
I will
route.
tell you, your standard access list should be done on different router. Extended is can be done in different router. I will teach you those things. Okay.
Okay.
Okay. Now we are going to learn types of rules. Your interview question. implicit rules and explicit rules. You have any idea what is implicit and explicit? Those who are working professionals, have you ever heard about it? What is implicit, explicit? No. So when you go, how many CCIE students? You will come across this term a lot in your CCIE. Okay, especially in firewalls. Implicit means predefined. It is a predefined rules. And it cannot be modified. And explicit means user defined. User defined rules and it can be modified. Okay. See, you will learn this in your firewall, but here I'll give you a small introduction to it. Okay, it is interesting. Your firewalls are very interesting to learn. So I have a firewall here. Okay. And I have two routers like this. In between, there is a firewall. This is my LAN router and this is my WAN router. Okay. What is this predefined rules? I'll tell you. Okay. This is my what network? We say inside. This is outside. Okay. So by default, this firewall, what it will do is when I say inside and outside, it will take this outside as security level 0. Okay. And this inside as security level 100. So that any traffic that comes from outside to inside, it will not allow by default. That is your predefined rules. Okay. But you can change it. That is your explicit rules. But by default, your firewall will take it as 0 and 100 security levels. Those are predefined in your firewall by default only. And it cannot be modified. Okay, that is your predefined rules. So you will make multiple policies here. Okay. So that you will learn in your CCIE. Okay, written implicit and explicit. Okay. Add one more point. After this implicit and explicit, at the end of, this is very important rule. Okay. They might ask you in interview also. The point which I'm going to give you now. Okay. At the end of every access control list, at the end of every access control list, there is a implicit deny statement. Implicit deny statement that denied all the traffic other than the access control list configured. That I'll repeat once again. At the end of every access control list, there is a implicit deny statement that denied all the traffic. That denied all the traffic other than the access control list configured. This you will understand in your practicals. This point, okay? And next point, write it down. The implicit deny statement is not visible. Next point, the implicit deny statement is not visible. Written. Written. And write down inbound. Inbound means for incoming traffic. Outbound means for outgoing traffic. So you can say like this. ACL is applied on two directions. Where relate? Oh. ACL is applied on two directions. One is inbound and outbound. Nibin, I've covered almost the basics of access control list. Okay. Nibin, covered the theory part. I'll explain practicals, you will understand. But again, go and watch the video. Okay. All right. Now, in this access control list, we have two types. Okay. We have two types. One is named ACL. Okay. So under this name ACL, we have standard and extended. Then we have numbered ACL. Here also we have extended. Written. So what is this name numbered will? First of all, we'll see the difference between standard and extended. Okay. I'll give time to write. Just you can listen to the standard. Okay. So in your standard ACL, range. Okay, you can write it down. I'll explain again. Range 0 to, oh, sorry, 1 to 99. This is your normal range. It's your normal range, and then you have extended. 3002 199. Okay. And it can be, it can block the host or a network. All services are blocked. All services are blocked. Bidirectional communication is and this is blocked. Traffic is filtered based on source IP address only. Write down these things. Written. Now write down for extended. Source IP, destination IP, protocol and port number. Written. Okay. So we have two ACLs. That is standard. Okay. Still people are writing. Write down, write down. What is that watch? Star. Can you see time in that? Show me like this. Like this. I don't see the. Oh, white mark. Okay. You want, you can go out. Personal. Okay. Now we have standard ACL and extended ACL. Okay. So standard range, you can see 1 to 99, and this is 100 to 199. And extended ranges, this one and this one. That is 1300 to 1999, and then 2000 to 2699. Okay. This is fine. So what a standard ACL can do, it can simply block a host. That is, it can simply block 10.1.1.1 or complete 10.1.1.0. So complete network it will block, or one single host it can block. That is your standard ACL. Whereas your extended ACL, it can block a host, it can block a network, it can block a port number, it can block a protocol also. For example, if I have to block a telnet, then I'll block port number 23. Correct? So telnet can be accessed. If I block 443, then HTTPS cannot be accessed. Correct? That is your port number block. Okay. If I have to block a protocol. If I say block ICMP, then the ping will not work. Okay, if I say block TCP, then protocols which are comes under TCP will not work. Likewise, based upon protocol number, port number, host, and also network can be blocked in your extended ACL. Okay, and then in your individual service can be blocked in your extended ACL. Like I said, if I want to block only ICMP, then only ping will not work. Correct. Whereas in your standard ACL, everything will be blocked. Complete service will be blocked. TCP, UDP, whatever the services, protocols, port numbers, completely it will be blocked in your standard ACL. Whereas in extended, you can do it according to your use. That is the difference. And here bidirectional communication is blocked. So I have R1 and R3. If I'm going to block R1 to R3, even R1 cannot ping R3. That is fine. That is my rules and it works. But R3 also cannot ping. That is what? Bidirectional. Whereas in your standard, R1 cannot ping to R3, but R3 can ping to R1. That option is there. Okay, so that is why unidirectional and bidirectional. We will see all these things in your practicals itself. And here the filtration is based on source IP. Whereas in your extended, source IP, destination IP, and protocol, and also port number. You can block based upon all four. So clearly you can see extended is more better, right? So we use extended in real time, not standard. So we have numbered ACL and also named ACL. In real time, they prefer only named ACL because it is more readable, more easily manageable. You can add lines in between. Whereas in numbered ACL, it is fixed. If you want to add a ACL, if you want to add another rule, you have to create another ACL in your numbered. In your named, you can insert in between. And also, named is more easy to understand because I'm going to give a name called, okay, block ICMP. Name can be given. But in your numbered, it will be a number 111. So you will not understand what is this 111. So that's why to have clear visibility, we are preferring only named ACL. Okay. Now we'll see the practicals. Any doubt on your theory? We have seen what is a access control list, where it is used, how it is. It is based on router's interface. Either inbound or outbound direction, it can be permitted or denied. That is fine. Then we have seen what is implicit and explicit. Implicit means predefined, you can't change it. Explicit means user defined, it can be modified according to our use. Okay. And in the important point which I given you, that is what? At the end of every access list, there is an implicit deny rule hidden. Okay. And it is configured by default. I will show you in practicals. This will be an interview question. Okay. So that is very important. And then after that, we have seen we have two types, that is named and numbered. Under named, we have standard and extended, and numbered, we have standard and extended. And what are the difference between standard and extended? We have seen. Now we'll jump into practicals. What about online, guys? Any doubt?
No, sir.
So there are 8 people in online. Only 3 replied. One replied through audio. Other said no, no in chat. What about other 5 people? Are you guys there? Please respond. No.
Well, I was having my problem.
Okay. Then use the
And
chat window and say no, I don't have.
uh,
Then only I'll come to know that if you guys are clear. All right. So I've taken 10.1.1.0, 11.1.1.0, and 12.1.1.0. Or I will take based on router number. It's more easy for you guys. 12, 23, 34. Now you're comfortable with this 34, 23, right? After doing multiple practicals. Okay. So I'll quickly assign the IPs. Do one thing. R1. Enable configure terminal. Host name R1. No, I'll change this to PC1. PC1. Okay. Interface gig 0/0. IP address 10.1.12.1, right? No shut. Okay. Copy for R2. Paste. This I will say R2 itself. 0/0. This will be 2. Correct? (23.2) gig 0/1. Done. We have R3. Host name R3. Address is what? I'll do it here. 0. So 23.3, right? And then we have gig 0/1. That is 12.1.34.3. Here it is 11. Here also 11. Correct? Then we have R4. This is the way you have to do the practicals in your CCNP and all. Use the notepad. But I suggest you don't go with it till your CCNA because you will get used to it. 12.1.34.4. Done? Yes, yes, yes. Okay. So go to this. I'll do the routing also. So I'll simply configure router rip. Simple. Okay. Router rip network 10.1.12.0. Here you have network 12.10.0, 11.1.23.0. Copy. We have 11 and 12.1.34.0. And for R4, we have only this one. Correct? Done. Now just copy paste on every routers. No auto summary is there in version 1. That is completely class full. Paste, enter. Done. See, this way, if you do the practicals, error will be very less. And it will save your time also. But get command over your CLI. Then go for this. R3. Done. Now go to R4. Okay. Now I'll simply ping 10.1.12.1. Connectivity is there. All good. Now I'll change this to, I'll say this as PC1. This is PC2. How I'll change this to PC means you say no IP routing. Give this command no IP routing, and then you are going to say default router is what? What is the default router for this PC? This interface, default gateway. So 10.1.12.2. Say IP default router, default gateway. Your thing will tab will not work. So two things I'm going to give. No IP routing, and then IP default gateway, the gateway of that PC. Okay. Because I have to do the telnet access. That's why I'm changing it to router. In GNS, you will see these things. Okay. No IP routing, IP default gateway. What is the gateway here? 12.1.34.3. Very good. Okay. That is this interface, 34.3. So now we are given the interface. Now try to ping. Do ping 12.1.34.4. Pinging connectivity is there. So now I'm going to show you numbered standard ACL. Okay. Your standard access list should always be, if I have to block this PC1, I mean, my goal is what now? PC1 should not ping to PC2. Okay. PC1 should not ping to PC2. That is my goal. So always your standard list must be configured near the destination router. Okay. So where I'm going to configure, what I have to ping, what is my rule now? PC1 should not ping to PC2. So this is the destination. Which is the router near to destination? R3. So I'm going to do my access control list on your R3. Okay. See, I'll say show access list. Is there any access list? No, not created. Now I'm going to create it. So what is the command means? Access list. It is what? Standard. Numbered standard I'm going to do first. So what is the range? 1 to 99. So I'll simply say 1. Okay. Access list 1. I'm going to deny host. What is the host I have to deny? 10.1.12.1. 10.1.12.1 should not ping the 12.1.34.4. So I said access list 1, deny the host. Okay, and I said this host. Give enter. Okay, next important thing is access list 1, permit any. I'm saying first I've denied the host and I'm saying permit any. If you can use your logic, you can answer this question why I'm giving this command. Tell me.
You can use any network apart from this host.
Yeah, that is fine. Why I'm giving that? That's what it means. Deny host this one, permit any means permit any other things. Why I'm giving this? This will be your interview question. Why I'm giving this command? What number? No. Okay, one clue I will give you. There might be some other. No. One clue I'll give you. Answer is in your notes. The important part is that correct. The important point I said, right? So there is an implicit deny hidden statement that is denying all the traffic. Okay, so that is the reason we are giving this command. So this is how technically they will judge you. Do you know access control list or not? Okay. First, what is the thing means? Wait, I'll show you this. Okay. Now I permitted any. Everything is fine. This is creating access list. Creating access list. Now I have to apply it. Where I am going to apply it? On the router's interface. So we have two interface gig 0/1 and gig 0/0. So here I'm saying gig 0/1, for example. Interface gig 0/1. Okay. This is inbound or outbound direction? Outbound direction. So I'm saying IP access group. What is the access list number? 1. And I'm saying out. Enter. That's it. Okay. Now say show access list. Now we have access list created. What does it say? Standard IP access list 1. Number 1 is created. So first rule is what? Deny host 10.1.12.1. Okay. After that, imagine if you are not giving this permit any. So here you can see one another space, right? This is your implicit deny hidden statement. So this statement is denying every traffic. Okay. For example, if I'm having 12.1, 12.2, 12.3, 12.4, 12.5, I'm having 5 PCs. I have to block only 12.1. In that case, if I don't give this permit any, then entire network will not be able to ping. Okay. So there is a implicit deny statement that is denying all the traffic. So what I'm going to do, I'm going to say permit any before that deny statement so that it will take this statement, not the implicit deny. So in this case, what will do? 12.1 will not ping, but 2, 3, 4, and 5 will be able to ping because I've given permit any other than that. That rule will come above the hidden rule. So multiple ways they might ask you a question. What is implicit deny rule? Okay, what is the use of this permit any? What if I don't give permit any? Okay, concept is same. They'll twist the questions according to the interviewer. If you understand the concept, you will be able to answer all kind of questions. Okay. Now see.
Can you say that after that you wrote no interface G0/1? That can you explain why you selected G0/1?
Yeah, see two interface there. Correct. Your access list are always applied on router's interface. So only two interface are there. Gig 0/0 and gig 0/1. You can apply it on both the interface. Here I've chosen gig 0/1.
G1.
So 1 is what? Outgoing. So that's
Yes.
why I've given out. If I would have given interface gig 0/0, I would have given here in.
Hmm.
Okay. Now I will try to ping. What can you see? Unreachable. Destination was unreachable, not failed. It is unreachable because I've created a policy. Okay, now I'll try from here to here. Here, it will not be unreachable. Here, it will be failed because bidirectional. I have applied the rule for 12.1 only. So that is unreachable. This is failed because bidirectional communication is blocked in standard ACL. Understood? Okay. Any doubt? Okay, I'll give you the comments. You can write it down. First two lines are for what? Creating a access list. And after that, these two comments are applying it. First is creating the access list. Next one is applying the access list on the interface. And in one interface, you can apply only one access list, one direction. So in direction, you can apply one, out direction, you can apply one. So other side, you have another interface, in direction one, out direction one. So only 4 access lists you can create. So in one interface, you can create only one access list on one direction, not multiple access list.
For this, can we apply on a interface G0/0 and same IP access group?
Yeah,
One in.
I will show in different. We are having 4 practicals. So other thing I
Oh,
will show in 0/0.
oh.
Written, guys. So now I'll remove it.
So Kamal, you said it is bi-directional, right?
Yes.
So you're saying it can be applied only once or on the interface.
Yes. That means one access control policy. So this policy is what I've created on this interface 0/1. That is out direction. I can't create one more access list on gig 0/1 out direction. No, I can't do that. What is remaining? In direction is remaining.
Okay.
Now I'll delete it. How? Just say no. First I deleted the access list, then go to interface and say no. Done. Now go to this PC. 100% pinging. Go to this PC. Pinging. Fine. Okay. Now I'm going to show you numbered extended. Okay, now we have seen numbered standard. Now we will see numbered extended. See, numbered extended ACL can be applied on any interface, any router. It doesn't need to be near to the destination router because there we are filtering it by a specific protocol and also port number. So that will not affect. And it is unidirectional also. It will not completely block a network. Okay. So I'll do it on this router too. So access list. What is the range? 100 to 199. I'll say 111. Okay. And I'm saying deny ICMP. Okay. I'm denying ICMP. What host? 10.1.12.1. Okay. And what is the destination host I have to block? 12.1.34.4. Correct. Access list 111. Extended ACL. Deny ICMP host is 10.1.12.1. Okay. Here, again give question mark. Here you can see echo reply, right? I will just block only the echo. Only the request packet I'm blocking. Reply packet I'm not blocking. Okay. After this, access list 111 permit IP any. This IP any means any protocol, any port number other than this permit. Okay. Any protocol, any port number other than this permit. That is the meaning. Okay. Enter. Now we have created the access list. First I blocked this source should not ping this destination. And then I said permit everything. Now created access list. I'm going to apply it on the interface. Interface gig 0/0. Okay. That is this interface. So traffic is what? Coming in. Correct. So IP access group 111 what? In. Okay. Now go to this PC. .34.4. Destination host unreachable. Here it will ping. Okay. But why it is pinging here? No. Okay. Unidirectional is fine. Another one reason. Huh? No. What command I've given here? No.
Yeah, you blocked only echo, not
I block
request.
only echo packet. I did not block the ICMP protocol. I blocked ICMP protocol in which only the echo packet. Okay. If I don't give this echo message here, then reply will also not work. Okay. So that is the advantage we have in extended ACL. Okay. Reply packet is coming in, but echo request will not work. So the employee cannot ping to manager, but manager can ping to employee. Understood? And also see here, I will say Telnet 10.1.12.1. 1, 2, 3. See? Other protocols will work. That means what? Your Telnet is working, but only the ICMP is not working. Understood? This is your extended ACL. This is what? Write it down. Devidas, okay. Gig 0/0 in direction.
Yes, yes, yes.
Out. What is the difference between privilege and access control list? See, privilege is like authorization. I'm telling you, you can do this much. Access is I'm blocking. Their privilege doesn't matter, whatever the privilege is. If the privilege is 15, I simply say block port number 23. Then what's the point of the privilege there? So your access control has to allow you first, and then you can set the privilege. Privilege is something that you are authorized to do. Access list is completely blocking a traffic. Okay.
Only blocking the traffic, not allowing.
We are allowing, right? Permit any.
Can you see the router?
Can we use?
Any router in between at most.
Yeah, any router you can use. If there are 10 routers in between, you can use any router. Standard should be only next to the destination router, but extended you can use on any routers. See, if you want to allow traffic, it's already been allowed. Everything is already allowed. If you just configure Telnet, it is allowed. But where this access list comes, if you want to block a traffic, by default, everything is allowed.
So that for extended ACL, we will apply always through in data
No,
interface.
it is depends on the interface. Whatever interface I'm giving, I'm going to give the in and out direction, not only in, not only out.
Oh.
Why are you getting this kind of doubts?
No, in standard ACL we applied out no. So
That's what I said, right? It is applied on both direction. Did you understand the theory part or not? See here.
Yes, sir.
See, ACL is applied on two directions, I said. One is inbound and outbound. Did I explain any standard extended here?
No,
Don't
no.
get confused.
Oh.
Okay.
Yes, yes. For example, you just did this out like that.
Yes. One I'm saying in, other I'll say out, in, out.
Anything we can apply.
Correct. Okay, written guys. Now we'll see named.
Nearly 2 times. You can use only one time.
I'm saying protocol any. There, only the host and network. But here, protocol, port number, IP. Everything is there. So IP any means any protocol any and network also. Okay. Now I'll delete it. How to delete it? Use the up arrow keys. Control A so that the cursor will go to the beginning. Okay. Say no. Okay. And then interface gig 0/0. IP access group. No. Cleared. Now go ping 100%. And here also already it is 100%. Fine. Now I'm going to show you named extended. Now what I'll do? I'll block this PC2 should not ping PC1. Now we have seen left to right. Now we'll see right to left. So this is the destination router. So I'll do the access list on then nearby router. I'll go to router 2. So IP access exit IP access list. What is the access list? Standard. Correct. And what is the name I'm going to say? Block PC2 to PC1. Okay. Block PC2 to PC1. Enter. And then you're saying deny host. What is the host that I have to deny? 12.1.34.4. Okay. And then I'll say permit any. This much is for your creating access list. Now I'll apply it on the interface gig 0/0. Okay. I'll use this interface. So it is in direction or out direction now? Out direction. Okay. So I'll say IP access group. And what is the name? Copy, paste. Okay. And out direction. Correct. Enter. There we are giving the IP access list number. Here I am giving the name. Okay. So initially it was pinging to PC1. Now say destination host unreachable. Okay. And if you ping here, it will be failed because bidirectional communication is blocked. This is your named extended. Here, every line is first we are creating the access list. I'm just saying this is a standard list and this is the name. Okay, then I'm denying the host. Then I'm permitting. Whereas in your numbered access list, everything will come in same. Host, which I'm denying, destination host, which I'm denying, what is the number of the access list extended, everything comes on single line. So that's why visibility is less, we say. So in your real-time environment, they prefer this. So they know exactly the name can be given according to our need. So they will know exactly what protocol, what PC should not ping. Okay, so we are preferring named extended ACL. Okay. But you can do the practicals of everything. That is, I will show you 4. I don't know if you guys doing it or not. Are you guys doing?
Sir, now you showed standard or extended.
Now I showed standard because I've given the name itself standard, right? In the command, did you see?
Yes, sir. You said it was extended.
Okay, my bad. I came out of mode. This is your named standard. See in your here itself we can see IP access list standard and I'm giving a name. That means what? Named standard ACL. Named standard ACL.
So just a doubt regarding that the message when we get when the ping fails,
What happened?
the message that we're getting while the ping is failing,
Yeah.
it is either unreachable or failed. So is that something consistent? Like just looking at the message, can we understand that okay, so this is unreachable. This means it is because of a policy
Yeah. See here, I've created the policy for
blocking.
this.
The
That is 1234.4. I've created the policy that this should not ping this one.
Yeah.
Okay, so that's why here it is unreachable
Yes.
because I've created the policy, so destination host is unreachable. But
So
here, I did not create any policy.
yes. So does this mean that whenever we see the messages like unreachable, it means it is because of a policy?
No, not always.
Policy. Okay.
Sometimes there might be a mismatch of IP. There might be no IP. Network might be there, but IP might not be there. In that case, okay.
Oh, okay.
In access
Okay.
control list, yes. If it's you, then means policy is applied. You can imagine.
Okay. So thank you.
Okay. Make sure you do all these 4 practicals tomorrow, okay? Because access control list is very important as of CCNP and CCIE. You will do a lot of practicals there. Only if you understand all 4 practicals, then it will be easy there. They're not going to explain very basically like this. Straight away they will jump. How many of you did this DR-BDR practicals? Raise your hands. Tall enough. Why? What about others? Why? I asked OSPF. EIGRP, what practicals is there? You're simply saying router EIGRP 100 network 10.1.1.0 wildcard mask 0.0.0.255. That's it. That is EIGRP practicals. Why your Dinesh is not done? Sandeep is not done. What about last 2? Why you didn't do? Himanshu. You had 2 days off, right? Huh? You know, in my all previous batches, I used to give a task every day after the class. They have to do the practicals. They have to take a picture of it and send it in the WhatsApp group. Have you ever seen the pictures coming in? You didn't see because you joined late. Because if you see, there will be like lot of pictures coming in my WhatsApp group. I will check each and every person's photo. Your batch I didn't do because your 26 people, 28 people are there. And I'm not sure if other trainers are doing it. I do it. Make sure you do the practicals. And if the picture is not come in class, I will exactly ask by the name why you didn't do. You do it, no? It's just CCNA. Here itself, you will have the lot of time here. Only 2 hours class, rest every time you have. Best time to prepare. Because once you start CCNP, advanced level will be there, especially routing and all. You will not have time. And you will forget 3 topics you will keep on forgetting. One is subnetting. Other one is DR-BDR. Other one is STP in your switching. These topics are very easy. While in the class, you will feel like I understood everything. But after 10 days, you will completely forget. Completely. So regular practice is required. Okay. Because what next week your CCNA is over. Then you should start preparing for interviews. Okay. All right. I keep telling the same slogan for every batch. And they come and sit in the interview. You know, when the people will get trouble, after completing all the course, they'll come to me saying, Sir, I don't know what to do. I've completed this course. Now I am going to start interview. You give me some notes or tips. What should I do? No point. You can't learn CCIE in few days or CCNP in few days. It's a process. All right. So this is the standard ACL. I'll just remove it. Done. I'll try to ping it. Okay. Now we'll do named extended. So access list, IP access list, extended name, I'll say block, I'll say block TCP. Okay. Now deny host, deny TCP host 10.1, sorry, 12.1.34.4. What is the destination? Host 10.1.12.1. Done. Okay. Now permit IP any exit interface gig 0 slash, I will say gig 0 slash 1, interface gig 0 slash 0, I'll say IP access group. What is the name? Log TCP. What is the direction? Out. Okay. Now ping is working. Telnet will not work. Correct? Ping is working, right? ICMP protocol is working. But see, it is keep on trying because I blocked TCP. So that's why it is not able to ping. Okay. Will it ping from here? Will it ping or not? 12.1.34.4. How many say it will ping? How many say it will not ping? How many say it will ping? Raise your hands. If you say no, I need reason. Raise your hands. You don't know. Say, you have to say, give an answer. You can't sit. So others are saying no. You're saying no. I'm asking now from PC2 to PC1 I pinged. It is pinging. Will PC1 to PC2 it will ping or not? Who is saying it will not ping? Raise your hands. Answer. That means it should ping, right?
But the entire protocol is blocked, right? TCP check.
Yeah. ICMP, I did not block. TCP only I blocked. But it will ping or not? It will-
ICMP.
This is how they will confuse you. It will ping. Because I did not block ICMP. I did not touch ICMP. Easy answer. Okay. All right. See, you will give a question. Okay, they'll ask you, what is the range of standard ACL? You will say 1 to 99. Is it 1 to 99? Then you'll say, no, sir, 100 to 199. They'll confuse you sometimes. Understand? If you understand, I did not touch the ICMP, right? Then ICMP should work. Be confident. Sometimes it's nice to be trainer, you know. Okay. Write down these two comments and your access list is over. Access list is interesting, no? Better than routing? Kind of interesting, no? Yes, it is interesting. Because you block, you allow, you permit. So you can do one thing. You can allow the telnet. Okay. You deny the telnet. You can allow the ping. Block the replay packet instead of echo request packet. Okay. One practical you can do, block the request, allow the replay. Other practical you can block the replay and allow the request. Other practical you can completely block ICMP. So that both sides it will not work. So likewise, you can keep on trying it. If you do that in such a way, your understanding of the concepts will become very clear. How many of you want Saturday class here? Raise your hands. 1, 2, 3, 4. Okay. Half enough. No class. Because your class is what? Monday to Friday. If everybody is okay, I can take. If 4 or 5 people are not okay, then no. Won't be able to make it. Okay. See, that's fine. We'll have Monday then. Tomorrow class is there. Monday. So I don't keep class more than 2 hours. If you take any batch, okay, and if you open any video of it in my drive, no class is more than 2 hours. Not even 2 hours. I'll keep it 1 hour 45 minutes. Because problem is when they're going to watch the recording again, they will see the timing 2 hours. Okay, they will not even see. These things happens. That too, they will keep into 2. Named examples will go like this. They will understand everything into 2 only. Okay, written. All right. Next, we are going to learn. So now your routing is over, access list is over. Okay. What is there means your switching starts by now. See, it's already 3:20. I don't want to start switching now. Fresh by tomorrow, I will start switching. So small protocols are there. We'll see that. Okay. NTP. That is what? Network. Huh? Time protocol. Transmission protocol. You guys are creating new protocol. And it works on UDP port number 123. It is used to synchronize the clock around or across network. Write it down. That is over a precise time source. It works on client and server model where client request and server response. So NTP is more advanced than SNTP. What is SNTP? Simple Network Time Protocol, not Transmission Protocol. Okay, write down these things. Written, guys. Small practical. See, if you are having 10 routers, okay, and all 10 routers will be in different time zone, correct? Here I'm taking only 3, but so I will take here 10.1.1.0 and here I'll take 11.1.1.0. Okay, go to this. First, I will say server. In server, enable configure terminal, hostname server. Okay, interface gig 0/0, IP address I will say 10.1.1.10. Okay, no shut. Interface gig 0/1. Copy, paste 11.1.1.10. Okay, and then I'll say router rip. So network 10.1.1.0, network 11.1.1.0. Then this is for server. Client 1, I will say enable configure terminal, hostname CL1, that is client 1. Okay, interface gig 0/0. I will say 10.1.1.1. Okay, copy, paste. Now completely copy this, paste client 2, hostname CL2, 0/0, 11.1. Here change it to 11. Easy, no? Notepad. You can also do this if you're comfortable enough with your. Once you got like complete command, I'm very, good with this CLI. I'm perfect. Then you go with Notepad. Okay. Enter. Server is done. Copy. Done. Go to your copy. Paste. Done. Okay. I'll say do ping 10.1.1.1. Pinging. Fine. Now come to your privilege mode and say show clock. Wrong time 1993. Wrong time. And this is also wrong time. Okay. So if we are having multiple routers, can we be able to configure the time each and everything perfectly? See, you can say, okay, the time is 3:29. That you can say minute, but can you be accurate on seconds? Because once you say, okay, 3:29 second is 15, and if you go to the next router, will you be able to configure on the same time? No. Correct. If the mismatch is between 20 and 30 seconds, it's fine. What if this mismatch is in 57 seconds and next 3 seconds? It will go to the next minute, right? So you cannot configure it on the manually on each and every router. So that's why we have this NTP protocol that is used to synchronize the clock across the network. Okay, and it works on client and server model. It works on UDP port number 123. So how I'm going to do it? So I'm going to change only on the server. Okay, so I'm saying clock set. Okay, I'm going to use the question mark always. If you use the question mark, it will say RR minute. See, RR minute, second. So what is the time? So I'll say 3:03. And what is the minute? 30. Second, I will say 35. Okay. And then it is asking for date. What is the date today? 3rd, 03, 3rd, 3 July 2025. Clock is set. Now the show clock. Clock is changed. But here, does the clock changed? No. So your NTP practically is very simple. One command. I'm just saying NTP master. The range is 1 to 15. So 1 is more trusted, 15 is less trusted. That is the distance server. So I'm just giving here 1. NTP master 1. Say NTP, my NTP server is 10.1.1.10. Okay. Same command, give it on. Okay. Now it will take some time to synchronize. In this case, we can use this fast forward button. You can't do it in real time. Okay. See, it is updated. Exact time. See, it's updated here also. So did I change the clock in my other routers? No. But your NTP protocol is used here. That is, it is used to synchronize the clock with the server. So I'll say show NTP status. Here the clock is synchronized with reference is what? 10.1.1.10. Okay. And also associations you can see. See, show NTP associations. So my system is what? 11.1.1.1. Correct. But what is the system peer here? System peer 10.1.1.10. But what is the actual NTP server? 10.1.1.10. Can you see the difference here? The small hyphen is there. That means configured. Okay. If you see star next to it, that is system peer. System peer means next to it. So this is the router I'm here. What is the system peer? 10.1.1.10. And it is configured on this side interface. So that details you can see in NTP associations. If I give associations here, show NTP associations. Here you can see only 10.1.1.10 because this itself is the peer and also the configured one. Okay. There you did see only this symbol, correct? But here you will see the star also. These kind of informations you will see in your comments. That is 2 comments are there. So status and so associations. Write down the comment. On server,
What is that 127 dot
127 dot.
127 on the CLI? You need to show association. Right?
Where?
I think it's on the server.
Where is 127?
When you said show association, you said only the server. Yeah.
This is the reference
Offset.
block. It is inbuilt. These are all inbuilt things. You can't change these things. So this will have the algorithm. According to that algorithm, it will change the clock and it will synchronize with the other clocks.
Okay.
Okay. As of CCNA level, only the basic thing is there. In server, NTP master 1. Client, you can say NTP server and IP address. IP, that is what? Not IP, just say 10.1. 1.1.10. Okay. Show NTP associations and show NTP status. 2 comments. Written. Okay. Another small practicals. Very small protocol written. Everyone. One is CDP. Another one is LLDP. CDP means Cisco Discovery Protocol. Write it down. This is link layer protocol. Okay. And here it is used to check the neighbors of the Cisco devices. So you have 2 commands, that is show CDP neighbor. And then you have show CDP neighbor details. So this is your Cisco proprietary. Cisco proprietary, and this is what? Open standard. And this is also same commands, just instead of CDP, we are using LLDP. LLDP and LLDP. Okay. And we have another command, that is CDP run to enable enable the protocol. Call in Cisco devices. And you have here you have what command? LLDP run. Sorry. Write it down, right? Written? Everyone written? Okay. Now I'll show you the practicals. Okay, now pinging is there. What is this CDP and LLDP means? To know the nearby devices. What am I connected to? That is your Cisco Discovery Protocol. Simply go to the switch, go to CLI and say enable, say, I'll change the host name switch 1. Okay. Okay. And I'll say show CDP neighbor. If you give this show CDP neighbor, I'm connected with client, I'm connected with server. And what is the model you can see here? Okay. Model of the router you can see. And what is the local interface it is connected? That means F0/1. See here, F0/1 is connected with client. F0/1 is connected with, this is client router. And you can see F0/2 is connected to server. And what are the interface they are connected to? Gig 0/0 and gig 0/0. Okay. So these things you can see in your CDP neighbor. And R means what? Router. Likewise, you can see. If I want to see the IPs and all, show CDP neighbor details. If you give this command, what is the IP of client? 10.1.1.1. And what is the IP of server? 10.1.1.1.10. So this kind of information you can get it from your CDP neighbors and details. So in your real time, you will not have this logical topology. So here I'm writing all the name, but in real time you can't see it, right? So we are using these commands. Okay. Now go to your switch, the other side switch. Show CDP neighbor. So it is connected with client 2 and also server. So what are the port numbers they are connected to? Same details you can see. And if you give details, you'll be able to see the IPs of it. Okay. Now I'll go to server and I say connected with switch. That is switch 1 and host name it did not change here. Did I give switch 2? Sometimes this bug is there, but it will not have it in real time. So you're connected with switch 1 interface. You can see gig 0/0 it is connected. On other side gig 0/0 the other switch is connected. So likewise you can see the details of it. Okay. Now I'll go to this router and I'll say show CDP neighbor details. Here switch 1. Okay. And you can't see IP because we don't have IP here for switch. And yeah, that's all you see. Okay. So this is the use of CDP, Cisco Discovery Protocol. What is the use of it? To identify the neighbor devices and which they are connected to which interface. Okay. What about LLDP? Same thing. Show LLDP neighbor. LLDP is not enabled. How will I enable it? LLDP run. I have to run it in all the devices. So LLDP run. Go to this router. Do show LLDP. Switch 1 it is connected to local interface gig 0/1 and it is connected via F0/1. Okay. And then same neighbor details you can give. Here you will be able to see the MAC address of it. See, MAC address of the switch you will be able to see. Okay. So this is the LLDP and CDP. LLDP is open standard and CDP is Cisco proprietary protocols. Okay. Any doubt? This topic I usually keep it on last day or last before day. Now we have time, 10-15 minutes we had. So that's why I just jumped into it. Because I don't want to start switching now. Switching will start separately today and we'll learn completely. Okay. So today what we have discussed, access list. So it is used to filter the network traffic inbound or outbound direction on the router's interface. Okay, so 4 types are there: name standard, named extended, number standard, number extended. Difference between standard and extended are, so here bidirectional, there unidirectional. Here only, so a host or network can be blocked there. Protocol and port numbers are added. Here only source IP is based on filter, but there protocol, port number, destination IP and source IP also. Okay, so these are differences, and we have seen 4 practicals. After we have seen NTP, that is used to synchronize the clock across the networks. Okay, with micro milliseconds. Okay, so for that purpose, we are using this NTP protocol. So it works on client and server model. So one we are saying server, others are clients, and this clients will get the time from the server. And then we have seen CDP, LLDP, that is used for the discovery of neighbors, which they are connected with my interface, local interface, and also their port ID, which interface they are connected through the link. Okay, so do all the practicals, and tomorrow I'll start switching. Okay, tomorrow's class will have little longer. Okay, any doubt, guys? Online guys?
No,
Okay, thank you. I'll see you guys tomorrow.